AI tools in TINA. Circuit design, code generation, and AI-controlled image recognition.
AI tools in TINA and TINA Cloud offer a flexible, user-friendly interface for various engineering tasks, including circuit design, simulation, code generation, and education such as
Providing information on circuits. Designing LDO and SMPS power supply circuits. Designing active and passive filters. Designing analog oscillators and digital clock generators. Selecting and redesigning evaluation circuits from different manufacturers. Generating Arduino code for rapid prototyping. Image recognition with Python or MCU. Creating step-by-step solution of simple DC, AC circuits. Creating quizzes and riddles and check their solution. Let's see how these tools work through examples. Redesigning a switch mode power supply. Open the TLS4120.tsc file from the TINA examples, design tool folder of TINA.
By default, this circuit produces 5-volt output voltage from 12 input voltage.
Let's check this with transient analysis. Click Analysis, then select Transient.
In the Transient Analysis dialog, press OK.
Redesign this circuit to change the output voltage to 3.3 volts.
While TINA already provides a dedicated design tool for this purpose, you can now achieve the same result by simply instructing the software using natural language.
Start the AI assistant by clicking the AI button. Then, enter the following instruction: set the output voltage to 3.3 volts with an output current of 1 ampere.
The AI assistant will utilize the design tool to automatically calculate and adjust the necessary component values, such as resistor values, to achieve the desired output voltage and current.
To check that the output voltage is 3.3 volts, drop cursor A.
You can also enter your instructions in various formats like I want the output voltage to be 3.3 V, etc.
You can enter your instructions in various languages depending on the LLM model you use.
Online models, e.g. GPT-4o, GPT-4o Mini support over 50 languages. You can also run TINA and TINA Cloud in more than 20 languages.
Redesigning a Colpitts oscillator circuit and providing information. Ask the AI assistant, what kind of oscillator circuits do you know?
The list of oscillator circuits will appear available for redesigning.
Select the Colpitts oscillator, then click OK. The AI assistant will load this oscillator circuit into the workspace. Once loaded, ask the AI assistant, what can you tell me about this circuit, or a similar question. The AI assistant will provide some key information about the Colpitts oscillator. Now, enter, show me the waveform of this oscillator. The results of the transient analysis, including the waveform of the oscillator, will be displayed. In the waveform viewer, place 2 cursors on 2 corresponding peaks of the oscillator signal.
The frequency of the oscillator can be read from the table,
approximately 2 MHz. Now redesign the circuit to provide an output signal with a frequency of 1 MHz. Enter the same text, or similar at the user field of the AI assistant.
Set the frequency to 1 MHz. The redesigned circuit will appear with the redesigned inductor L equals 5.07 microhenry selected in red.
Finally, run transient analysis to check the result. As you can see, the frequency is approximately 1 MHz. Generating Arduino code for rapid prototyping with AI in TINA. Open the AI dialog and enter the following. Create a simple Arduino code for generating prime numbers up to 100. Copy the code into the TINA Arduino code editor, then compile and save the project. Double-click the Arduino Nano board. Then click Enter Macro. Next, double-click the Atmega 328P_32 macro. Then click the 3 dots in the HEX, ASM, C code line. Next, click the C Project button in the MCU input file selection window. In the MCU IDE window, click the Add New File to Project button. then paste the code. Now, compile and save the changes. Close the MCU IDE window, then click OK in the MCU input file selection window. Click OK to close the Arduino Nano dialog as well. Select Serial Monitor from the Tools menu. Next, press the TR button to check the result with interactive transient analysis. The list of generated prime numbers appears on the screen of the serial monitor.
AI-controlled image recognition in TINA.
In the following, we will demonstrate AI-controlled image recognition using TINA.
The circuit in this example can recognize 5 different flowers: daisy, dandelion, rose, sunflower, and tulip from a JPEG picture. Some sample images are stored in the flowers folder of TINA. You can select from those or select any other picture on your computer, including pictures downloaded from the internet. The image recognition functionality is implemented using a TensorFlow model file. Creating such a file is briefly explained in the TINA manual and in more detail at www.tensorflow.org. Now, let's begin the demonstration. Load the AI image recognition by python.tsc file from the AI folder of TINA examples. Press the TR button at the top toolbar of TINA. This will initiate the image recognition process. After a brief processing, the logic indicator, labeled sunflower, will light up, indicating that the circuit has successfully identified a sunflower in the input image. To change the input image, double-click on the yellow image classifier macro. Scroll down to the last JPEG line and click on the file name sunflower1.jpg.
Click on the 3 dots at the end of the JPEG file line to open a file dialog.
Select the tulip1.jpg file from the flowers folder, press Open, and then OK. This will change the input image to a tulip picture. To start the recognition process again, press the TR button at the top toolbar of TINA. This will initiate another image recognition cycle, and after a brief processing time, the logic indicator labeled tulip will light up, indicating that a tulip has been successfully identified. Check this again with a downloaded picture from the internet. Let's download the opening picture, a tulip field of Wikipedia. Click the picture on the right at https://en.wikipedia.org wiki-tulip and save it to the Downloads folder on your computer as tulipwikipedia.jpg.
Once the picture is downloaded, change the JPEG line in the image classifier macro to the path of the downloaded tulip picture.
Press the TR button again to start the recognition process. This time, the logic indicator labeled tulip will light up again, indicating that the circuit has successfully identified a tulip in the new input image.
This concludes our demonstration on AI-controlled image recognition.
For more information, visit our website at tina.com. Visit our YouTube channel, youtube.com/user/Tina Design Suite.